LeetCode Problem 208, Implement Trie, a prefix tree. So this problem wants us to implement a prefix tree, which is a data structure used to store strings, right? And the reason why we have to use a trie instead of a traditional data structure is because we have to account for autocomplete and spell checker, right? So there is this function called starts with, where we have to return true if there is a string that starts with the prefix, right? The string that we previously inserted. Okay, so the way I did this was to use uh, obviously use the tries, but let's go through how I actually do it. So in this case, when we insert apple, let me just go through. So here I have the try node. So each node have 26 child, so 26 is the number of alphabets. And then I have a boolean here that will tell me whether or not this specific node is the end. Okay, I'll explain why we need it later, but just know that this try node will just initialize all the child as null, the end as false when it is constructed. Okay, so when I have my node starting out like this, and we iterate through all the characters, if you see here, I am iterating through all the characters. Okay, so initially I will construct a new try node on the root, right? And then the current will be the root, which is currently just a placeholder. It doesn't have any nodes yet. And then I iterate through every character in the word, and I will find the index, right? So what I'm planning to do is create a node called A, right? And this A node will be another try node where it can has like multiple characters underneath it as well, right? But for this instance, for this child A, if it is null, I'll create a new node, which in this case it is null, so create a new node. And then my current will be at A now. Okay, and then for the next node, P, I'll create another P, right? Another P, go into P until we reach the end. Okay, when we reach the end, the for loop will finish. For loop finishes iterating, and you'll mark this specific node as the end as true. This means that this node signals uh, the end of a word, right? Because the end of a word is E in this case, so we have E here. Okay. When we search over here, what I'm doing is I am iterating through all the characters in the word, and then I'm finding whether or not that node exists. Right. For this instance, since we're searching for apple, so you search for A, in this case exists, search for P, right? Because I'll iterate through and then I'll recurse into it. So P, not necessarily recurse, but I will iterate through the try. So P, L, and then when we reach E, the for loop ends, and then I will return whether or not this is a end of a word, which in this case it is, so this will be true. But let's say if it searches for something like app, right? App. Okay, so the same thing, you go to A, go to P, and on P, since this P is not marked as the end of the word, you return false, because there is no such word as app, since we have only inserted apple, right? Okay, let's move on. Let's try start with, right? So start with uses the same iterating algorithm as search, but the difference is I return true instead of checking whether or not this is a valid node. So start with app, so I go A, P, P. Okay, since nothing went wrong during the for loop, did not return false because there's no null nodes, so you just, sorry, I referred that. Nothing went wrong in the for loop, no null node was found, did not return false. So I just return true. This means that there is a word in our dictionary that starts with app, which in this case is apple. Okay, then when we insert another app, so what I do is insert, so I check if it's null, then I create a node. But in this case, since it's not null, so I just reuse the same node over here, and when we reach here, I'll mark this as end of a node. So when we search again, this will be returned true. Okay, so let's say if we insert another word, let's say we call uh, aspire, for example, right? It's a bit a long word, but what we do is we create a, since there's no s, so you create another s, and then in this s you go again, right? P I R E. Okay, so try to look like this. This will be marked as a end node, and if we add like ask, right? So you go to a s, then here you create a k, mark this as end node. So you can see how our try is like a map that finds the word, for example. Right? So these are just some examples. Hopefully that's sufficient. That's all I have to say. Thanks.